I'm going to make a circuit using this NPN phototransistor. And notice that it only has 2 leads. That's because the base is sensitive to light. It's already built in. And the next component I'm going to use is this MOSFET N channel. Now I've done a number of videos on MOSFET N channels, so I'm going to concentrate on the NPN phototransistor. Here I'm going to test the infrared phototransistor. The long lead is the negative lead, and of course the shorter one is the positive. I've got the meter set at its highest resistance setting. And the phototransistor is pretty sensitive. I'm going to change the scale so I can get an accurate reading of the resistance when I hold it right next to the light. And it reads at the highest light, or the lowest resistance, of about 180 ohms. I'm going to switch it back, the meter, to its most sensitive setting. Since this is infrared phototransistor, an NPN, it is sensitive to infrared coming from the remote control. This is the circuit that I came up with. A YouTuber was wanting to automatically turn some LEDs on at night and off during the day. Starting at the 12-volt power supply, he's going to use a car battery. If we go straight down, we see a 100 k ohm resistor. Then that's connected to the phototransistor, and with daylight we get about 180 ohms of daylight. We also have a connection that goes over to the gate of the MOSFET, but in this configuration with 180 ohms daylight, that's effectively shorting out the bias on the gate of that MOSFET, and I've got a light hooked up to this, but whatever you have hooked up to it, lights or LEDs, they are off. There is a small amount of current when the phototransistor is conducting during the day, and that works out to be 0.12 milliamps. So that shouldn't be any problem for a car battery for quite some time. Now, when we cover the phototransistor, it goes to almost infinite ohms, which means it's acting like it's not even there. So now we've got bias on that gate of the MOSFET, which turns on the light or the LEDs, whatever you have hooked up to the drain of the MOSFET and the 12-volt power supply. And here's a demo showing that. Here's a close-up of the breadboard. And as we saw in the video, when I covered up the phototransistor, the light came on. This is a very interesting circuit, but can be very useful. Now, depending on how many lights and LEDs you have on the drain of that MOSFET, you might need to add a heatsink. But that particular MOSFET is good for, I think, 16 amps. I'll put the part numbers of the phototransistor and the MOSFET in the show more of this video. Thanks for watching.